The Moon, our closest celestial neighbor, has intrigued humanity for millennia. Its pale light, its cycles, and its gravitational influence on Earth have inspired myths, scientific exploration, and countless theories about its origin. But one of the most profound questions in the study of our solar system and the history of our planet is, where did the Moon come from? For centuries, scientists have worked to uncover the true origin of the Moon. Over time, numerous hypotheses have been proposed, ranging from the Moon being formed alongside Earth to it being captured by Earth's gravity from an entirely different part of the solar system. Despite the advancements in technology and research, the Moon's origin remains one of the greatest unsolved mysteries in science. Did the Moon form naturally? Or was it the result of some extraordinary event, one that could forever alter our understanding of Earth's history? In this comprehensive exploration, we will delve into the various hypotheses about the Moon's origins, including the widely accepted theories and some of the more controversial ones. From the traditional theories to the cutting-edge discoveries made in recent decades, this investigation will cover the nature of the Moon's formation and how the answers could reshape our understanding of both the Moon and Earth itself. The traditional theories of the Moon's origin. Before we delve into the alternative theories, it's important to understand the traditional and most widely accepted explanations for the Moon's origin. Over time, several prominent theories have emerged, and among them, three stand out as the most significant: the fission theory, the accretion theory, and the giant impact hypothesis. 1. The fission theory was one of the earliest ideas put forward to explain the Moon's origin, particularly in the 19th century. According to this hypothesis, the Moon was once part of Earth and broke off due to some form of high-energy event, such as the rapid spinning of a molten early Earth. The most prominent proponent of the fission theory was George Darwin, son of the famous Charles Darwin. In 1878, George proposed that a rapidly rotating young Earth could have had a part of its outer layer separated due to centrifugal forces. This detached material, which would eventually form the Moon, was thought to have been flung into space, where it became Earth's companion. While the fission theory was an appealing explanation, it failed to gain widespread acceptance due to a lack of evidence to support it. For example, the Moon's composition, as determined through rock samples and analysis from the Apollo missions, does not appear to be similar enough to Earth's crust to suggest that it was formed from material that once belonged to Earth. Furthermore, there was no clear mechanism identified for how such a catastrophic event could have occurred early in Earth's history. 2. The accretion theory. The accretion theory suggests that the Moon and Earth formed together as part of the same process of planetary formation. This theory posits that, during the early stages of the solar system's formation, dust and gas particles clumped together to form both Earth and the Moon simultaneously. According to the accretion theory, as the young Earth formed, it attracted material from the surrounding space due to its gravitational pull. This material would then have condensed and clumped together to form both Earth and the Moon. This idea was largely supported by the fact that Earth and the Moon share similar isotopic compositions, indicating that they may have formed from the same material in the same region of space. 3. The giant impact hypothesis. Most widely accepted theory for the Moon's origin today is the giant impact hypothesis, sometimes called the Big Splash theory. According to this hypothesis, the Moon was formed from the debris created by a colossal collision between Earth and a Mars-sized body, often referred to as Theia. This event is thought to have occurred around 4.5 billion years ago, shortly after Earth's formation. The giant impact hypothesis explains several key aspects of the Earth-Moon system. For one, it accounts for the similarities in composition between Earth and the Moon, particularly the isotopic signatures found in both bodies' rocks. The hypothesis suggests that when Theia collided with Earth, much of the debris from the collision was ejected into orbit around the Earth. This material eventually coalesced to form the Moon. While the giant impact hypothesis is the prevailing explanation, there are still some unanswered questions, particularly regarding the dynamics of how the Moon's formation occurred and the precise compositio of the impactor Theia. Some scientists have even questioned whether Theia existed as a distinct body or if the impact could have come from a different source. The controversy was the Moon really formed naturally, while the giant impact hypothesis remains the most widely accepted. It is not without its critics. The origin of the Moon is a topic that still raises many unanswered questions, and some alternative hypotheses challenge the idea that the Moon formed naturally from a giant collision. These theories suggest that something far more extraordinary may have been involved in the Moon's formation. 1. The captured Moon theory. The captured Moon theory posits that the Moon was not formed alongside Earth, but was instead a body that formed elsewhere in the solar system and was later captured by Earth's gravity. According to this hypothesis, the Moon could have originated as a rogue planet simul, or even a dwarf planet that wandered through space and was drawn into Earth's orbit. This theory has been widely rejected by most scientists for a number of reasons. One of the primary problems with the captured Moon hypothesis is that the dynamics of capturing a celestial body into orbit are extremely complex. The Moon would have to pass through Earth's gravitational field in such a way that it would lose enough velocity to be captured, but not break apart. Additionally, the Moon's lack of a significant atmosphere or significant differences in isotopic composition between Earth and the Moon makes the idea of a captured body seem highly unlikely. Nevertheless, there is some evidence in the form of irregularities in the Moon's orbit that suggests a history of gravitational interactions between Earth and the Moon that may have been more complicated than a simple, the ancient Moon theory. Some researchers have proposed that the Moon may have existed long before the Earth did. According to the ancient Moon theory, the Moon may have formed as a separate object from Earth, possibly around the same time as the Sun and the early planets. This theory challenges the conventional timeline of planetary formation and suggests that the Moon could have had its own origin, independent of the Earth. The evidence for this theory is limited, but it raises interesting questions about the early formation of the solar system. Some proponents of this theory believe that the Moon could have been an early object in the solar system that somehow became gravitationally bound to Earth later in the system's evolution. However, this idea also raises many difficulties, particularly concerning the Moon's composition and the lack of significant evidence to support such an ancient formation timeline. 3. The artificial Moon theory. Perhaps the most outlandish of all the theories is the artificial Moon hypothesis. According to this theory, the Moon is not a natural object at all but rather an artificial construct created by an advanced alien civilization. Proponents of this idea point to various anomalies in the Moon's structure and behavior, such as its perfect size to create solar eclipses, as evidence that the Moon might have been engineered. Though this theory has been largely dismissed by the scientific community, it remains a popular subject in pseudoscience circles. Advocates of the artificial Moon theory often cite the mysterious features of the Moon, such as the presence of perfectly aligned craters and the peculiar ringing sound the Moon is said to make when rocked by meteorites. Future research and exploration, the key to unlocking the mystery. While the giant impact hypothesis is the most widely accepted theory for the Moon's origin, the mystery of its true formation is far from resolved. Researchers are continuing to study the Moon through a combination of space missions, lunar sample analysis, and advanced computer simulations. NASA's Artemis program, which aims to return humans to the moon in the coming years, promises to provide new insights into the moon's history. One of the primary goals of Artemis is to study the moon's surface in greater detail, potentially shedding light on its early history and its relationship with Earth. By analyzing lunar samples brought back to Earth during the Apollo missions, scientists have been able to gain a deeper understanding of the moon's composition and its history. Recent studies of these samples have raised new questions and potential avenues for exploration. In particular, new techniques in isotopic analysis are helping scientists to refine the timeline of the moon's formation, and more advanced telescopes and space missions may eventually provide answers to the remaining mysteries. Ultimately, the true story of the moon's formation may be more complicated than we currently understand. As new research missions and technologies emerge, scientists are likely to uncover more pieces of the puzzle. One thing is certain: the moon's origins will continue to captivate humanity's imagination for years to come, as we seek to answer the age-old question: did the moon form naturally, or is there a deeper mystery behind its existence?